Now, let us come to Reynolds number. What is this number? So, this number tells us that when the flow will be streamlined, laminar, unsteady and turbulent. For example, let us take the burning of a cigarette. So, you see this is the burning pot. So, we have seen that this is the laminar flow, the smoke comes out like this, and but soon after some time then it becomes turbulent. So, this is turbulent. So, up to this region this is laminar flow and tarvata, that is next, it is turbulent flow. So, now you see here, so when the velocity is less, the flow is laminar. So, when the velocity is larger, turbulent flow. So, Reynolds after a study of fluids at different velocities concluded that the flow is laminar at lower velocities and becomes turbulent at higher. In order to define, so he introduced some number, i.e. dimensionless quantities which determine when there will be turbulence or laminar flow. So, according to Reynolds, suppose a fluid flow through a pipe, then that dimensional Reynolds number is rho, V is the velocity, D is the diameter of the pipe by eta. So, this is a dimensionless quantity which describes that your flow will be laminar, turbulent or unsteady. So, there are some numbers. If Re is less than 1000, so this Re is less than 1000, flow is laminar. If Reynolds number is if this Re is in between, suppose 1000 to 2000, it is unsteady flow, means somewhat in between the laminar and this. If we have Re greater than 2000, this is complete turbulent flow. So, thus this Reynolds number is a dimensionless quantity which has come from dimensional analysis of different fluid flows, which this tells us, which gives some numbers, and these numbers depend on the geometry of the pipe or the cross section through which the fluid is flowing.